Okay, well, hello, everybody. My name's Adam. I work in the data analytics team within LIDA, the University of Leeds. I'm here to give the talk, Bridging Trust and Research, Exploring the Secrets of a Secure Environment. So we'll start with some basics. What is a trusted research environment? I mean, at its most basic, it's a computing environment where data flow is strictly controlled. So the ingress and egress of data, research data from that environment is only permitted through controlled means. It's often described as a walled garden approach. From within that computing environment, there's no access to internet or other networks, which makes them highly secure. And then any findings and outputs generated by that research can be released through, again, controlled means to ensure the security of the data within that environment. Why do we need them? Well, principally, they enable enhanced collaboration between organizations, where data can be shared and it can be, the participants, the collaborators can be trusted to treat that data safely. They're given there is an environment to do that. Because of that trust, because of that security, it enables more meaningful insights from larger volumes and more granular data. The data doesn't have to be aggregated or reduced as much, because of the security of the environment kind of mitigates much of the risk. There's assurances that can be provided to reassure data partners and collaborators that their sensitive data can be shared safely. And there's just a general a rising tide of data security standards in the industry, in research, academia, and also in the public consciousness. So TREs enable us to bring the analysis to the data, and the residency of that data can be controlled and guaranteed. And it's that public trust is becoming increasingly important. TREs not only help us to process and analyze data in a secure way, but in a way that we can be seen to be processing and analyzing that data in a secure way. So who's using ours? Here's a selection of data partners that have entrusted their data with researchers at University of Leeds, and are using our TRE, many of which are known for their own security and sensible treatment of their own data. I think the fact that they've shared their data with us speaks volumes to the power of a trusted research environment. Okay, so a bit about LIDA. This isn't the purpose of this talk is to really focus on our trusted research environment, but within LIDA, we do more than that, so it would be a shame to not at least give it a mention. We bring together researchers and students in data analytics from a broad range of disciplinary backgrounds to advance knowledge and improve well-being and prosperity through well, internationally outstanding research and education in interdisciplinary data science and artificial intelligence. We have a community of over 600 individuals engaged in research programs, collaborations, seminars, 300 researchers, academics, PhD students, professional services staff from across campus, about 10 university departments. And we're physically located in the Worsley building. So we have that physical, collaborative, multidisciplinary space. There's some case studies on the research conducted in LIDA on the website. Go to that link or scan that code to find out more. Like I say, the purpose of this talk isn't to focus on that. It's to focus on our TRE. Now we call it LASER, Leeds Analytic Secure Environment for Research. It's built in Azure, so it's all cloud-based. It's a secure environment for handling, processing, analyzing the data. Because it's built in Azure, up in the cloud, it is flexible and scalable. So there's the diagram on the screen here kind of gives a high level view of what a TRE is within LASER. Essentially, a trusted research environment is a group of resources. At its most basic, a virtual machine and some storage. But the flexibility of Azure means that we can add all different resources, SQL servers, you name it. The scalability of Azure means that we can increase the number of virtual machines, the volume of storage, the size of machines. We can put what we want in there, and we can have it any size that we need. Depending on the requirements of the research. And it's all segregated at that network level. So each trusted research environment is segregated from each other trusted research environments. It's on a project by project basis. So researchers connecting into virtual machines in one TRE can't see any resources from another TRE and vice versa. There's no internet access. Like I said earlier, the data flow is highly controlled. It complies to high security standards, ISO 27001 certification, and we're compliant with NHS Data Security Protection Toolkit. So those data security frameworks are really useful to provide those assurances to data partners. Almost like a shorthand for we meet these standards. It's a safe place. The data that is used within LASER is classified and controlled according to its data sensitivity and confidentiality. We operate a risk-based model adapted from the one that Alan Turing Institute published. 5 tiers of risk. Tier 0 is super open data. Nobody really minds who can read it, all the way up to tier 4, which is your really sensitive stuff that has to be quite tightly controlled. We run role-based access controls so that we've got granular control over various mitigations for that data. For example, we can within a TRE, we can restrict access to folders for certain user groups. We can restrict which resources within a TRE virtual machines can access, so we can group them that way. We can restrict groups of users to groups of VMs, all that good stuff. And for the most sensitive tier 4 data, we've actually got some physical spaces within LIDA, safe rooms, that we can restrict TREs to. So the TRE, the most used TREs are remotely accessed. But for that top tier of data security, we can and do restrict access to a safe room within LIDA. So you have to actually physically come in, and they're controlled spaces, not allowed any phones or recording equipment. Bookable spaces within LIDA. This is all managed and maintained by University of Leeds IT Services and operated by ourselves, the data analytics team in LIDA. And when researchers use a TRE, they connect to a virtual machine. The virtual machines within TRE can all see the same project shared storage, unless those controls that I mentioned earlier have been applied. It's all dependent on the data risk and the data sharing agreements that are in place, what the requirements of the project are. But generally speaking, the virtual machines can all connect to the same shared storage and other shared resources, which are inaccessible from the other TREs. Software can be installed to and run directly on those virtual machines. So it's just like working on your computer, except it's a remote computer within a secure environment. So just to move on to data analytics team and how we support the use of LIDA, we've developed a research management process that supports projects and PIs from cradle to grave of their project, from the inception, the generation of a research proposal or a grant application. We can help to design project in terms of mitigating risk at source. I always say if you don't need to use LIDA, if there's no requirement for this level of security, if we can de-risk the data at source and still have meaningful research, that's the preferred option. So we can help with those discussions, but oftentimes the research does need data that is classified at a risk level that warrants the use of LIDA. So in those cases, we work with the research teams, we work with IT services, we work with information governance teams within University of Leeds, and the data owners to generate a set of requirements. We translate those into costs that can then be put into the grant application or business case, depending on how it's funded. And then on successful funding, we move through this research management process. We build the TRE. We've got support set up for setting up data sharing agreements and collaboration agreements and non-disclosure agreements, all that contractual stuff that needs to be in place as well. So once that's all signed off, fully executed, the TRE has been built, we can start importing the data. Again, that's data analytics team. It's part of that controlled data flow to and from the TREs. Once the data's in there, the researchers can conduct their analysis, write the papers, generate their outputs, which would then be exported via the DAT. We complete and close off the project. So that's the research management process. In terms of actually conducting the research within a TRE, I mentioned earlier, applications are installed directly to those virtual machines. We make software available. There is no internet access. You can't just download an exe and install software yourself. So we have a pipeline software center through which software can be provisioned directly to VMs. So it's all self-service. You find the software you need. The majority of use cases are available on Software Center, but others are available on request. So if there's something that a user would like to use for their analysis, we can make it available. There are challenges that we faced with a lot of these software, such as Python and R. They're quite package dependent. There's a need to connect to external repositories of packages. Without an internet connection, that's just not possible. But without those packages, Python's pretty useless, right? So there's the So here's just an image that describes that. So we couldn't do that. So how we solved that problem was with a piece of middleware, air-gapped middleware, a repository manager that handles those connections. So the TRE environments can be set up so that rather than pointing, for example, directly to Conda repositories, they'll point to this repository manager, and then that points to Conda. So once it's set up, it's a one-time thing. It functions just as it would with with an internet-connected device. Conda install package, pip install package, and this repository manager looks at these repos, or checks itself first, actually, see if it's already been downloaded and available. If it's not there, it reaches out to these repos, pulls the packages locally to within the LASER environment, and then makes it available to everybody within LASER. And what that means is we've got that air-gapped control over what these TREs have access to. And should we receive a request to make another repository available, we can easily add it, and we've got that control. But there's also the usability as well. So moving on to imports and exports. Like I say, the data analytics team are responsible for imports and exports to and from LASER. We have a secure transfer mechanism that we can use and make available to everybody using LASER, including the data owners, who we work with to ensure the secure transfer of that data. We review everything that comes in and out against data sharing agreements and other applicable obligations. We run a disclosure review before releasing it from LASER or making it available to the researchers within the TRE. Anything that fails this review is destroyed in a secure fashion. And it's kind of, it gets logged and reported. Everything gets logged and reported, all file transfers and asset registers. We've got full auditability. And again, that provides that kind of that additional assurance that we've got the data analytics team acting as a trusted third party to ensure the secure handling of research data. Okay, live demo time, right? Nothing screams confidence like a live demo. I'm going to hand over to my colleague, Ifeanyi, who's going to take control of the screen for a while and just show you LASER in action, show it in use. Ifeanyi, over to you.
Thank you very much, Adam, for the wonderful presentation. I will just quickly share my screen and take you through the live demo of the TRE that Adam has talked about, LASER in this case. So when a researcher has been given access, to LASER and has been onboarded into, the LASER system, so a researcher or a user with an internet access just log into their computer device and type laser.leeds.ac.uk on the browser on the computer with internet access, and they will be prompted to sign in using their username and password, the University of Leeds username and password, which will be given to them. And when they sign in to the system, if they are using the system for the first time, they will have to set up the security, the University of Leeds set up double two-factor authentication, and they will be asked to prove or show that they have installed the Citrix workspace app, which is the system that enables your local machine to communicate with Laser storefront. So here we have the Laser storefront, and because I have higher level of access, you can see the number of VMs that we have here, more than 120 or 226 that we can see. So usually users will see the few level of access that they have, perhaps 1, 2, 3, or as the case may be. So today for our live demo, I'll be using the test VRE or the test TRE that we have here. So a user would log in and click on which of the virtual machines, in this case, this particular one here. And once they click on it, it takes a couple of seconds, 10 to 20 seconds to load up, and it will pop up a system like this that is just showing on the screen. So this is a standard Windows 10 machine, and just very few things about this device. Just like Adam mentioned in the beginning, it doesn't have internet access at all. So for example, if you want to type anything, access the internet here, you cannot really access the internet because it is air gapped controlled, and also users cannot copy and paste items from their local machine to the virtual machine, the VMs, and they can also download files directly from the VMs to their local machine or upload files from the local machine to the VMs. So for every data transfer or data process, it's reviewed by the DAT team, and to ensure that every data flow has undergone the data security and compliance criteria. Similarly, when a user wants to install software, this machine comes with a lot of software already pre-installed. So, but when a user wants to install other software that is not already pre-installed, we have a system called the software center. So they type the software center and choose which software or packages that they want to install. Just as Adam mentioned as well in the beginning, we have Python packages and R packages that users can use to do their research. But because there's no internet connection, so we use a system that is repository manager to enable users to use which Python package or R package of interest. So in this case, I will just demonstrate a Jupyter Notebook script and file and show how users would run a simple Jupyter Notebook file and generate an output. So in this case, I would open this file, this Jupyter Notebook file for users, and just run this notebook file to generate some outputs. And so this is a dummy data. Doesn't really contain any sensitive data. This is dummy data that is generated from some random codes here that is illustrating the age of people and their salary. So when researchers and users do their research and generate very amazing plots and charts using Jupyter Notebook or any other research software that they need, And so they save this output, the plot and the charts that doesn't really have any sensitive information. And usually they save these charts within the shared storage that Adam talked about in the beginning as well. So the shared storage here, which every VM that has access to that TRE can have access to the data. So in this case, a researcher saves the data in the export folder, and then we help them to, we review this data export request and export the data for them to ensure that it's, meets the compliant data security compliance. Finally, when a user is done with their work here and before they sign out, so they need to click on the shutdown button here, the red button on the screen, to help them to shut down, because as soon as a user clicked on the VM in the storefront, it starts to charge the project an additional money. So when they finish their work, they have to click on the shutdown and the work is done. And that is in a nutshell what LIDA is and how it can be used. So thank you very much, and I'll hand back over to Adam.
Thanks, Ifeanyi. Great stuff. Share my screen again. Okay. So that was a live demo. And speaking of costs, there is a cost. There is a charge for using Laser. Like I mentioned at the start, it's all built in Azure. So Microsoft do bill us for using Laser. The costs of Laser vary project by project. Every project has different requirements, different resources, different usage patterns. So this slide really is just illustrative. I think the prices were taken. Oops. The prices were taken a little while back, so they may not be strictly accurate now. But I think as an illustrative example, it's fine. I'm trying to demonstrate that the more you use resources in Laser, the more they cost, and the larger the resources, the more they cost. As you can see here, a standard VM that's not used a lot might cost you £10 a month, but a larger one that's used constantly, you're looking at closer to £500 a month. So there's quite the variance in that. And as part of that research management process, the early stages when we generate these cost estimates, one of the challenges is to try and determine the level and scale of resources that are required for that research, and how much they're likely to use them. It is a challenge. We never get it spot on. We can, make the assumption that people are going to use it for, 5 days a week. But generally speaking, the real usage will never quite match up. So we can do what we can, but it's more of an art than a science, really. Those are the direct costs for using Laser. That's what we, as a university, get charged for using Azure. There are additional costs to cover the DAT support that's required. And again, part of the RMP is trying to determine how much support is required from the DAT. Is it just a standard single import of data that you crack on, or is the DAT involvement more than that? Is there frequent transfers? Are we can we be used for some of the data management or analysis, or some projects have members of the DAT embedded in the team and actually work in there. All that kind of falls out of the research management process, and again, depending on the funding, is quite flexible. But like I say, it is more art than science, trying to predict what those costs will be. So we have also developed tools to help Laser users monitor these in close to real time. You know, Microsoft have their Azure portal, and we've got a laser dashboard, so you can monitor costs that are actually, you know, real costs accrued against the project, against budgets. You can see who's using the TREs, which resources are being used and how much they're costing. And you can kind of monitor the usage patterns that way. The costs generally are less than a lot of people kind of believe. You know, we've got 50, 60 projects currently on. We've supported many more over the last few years, and over half of those project months cost less than £50 a month. You know, a third cost less than £25 a month. You know, the average across all projects that have been on laser is about £1,000 a year. And like I say, there's that support costs on top of that. So now I'd like to hand over to some actual researchers that have been using laser. Give us their testimonials. So we'll start with Susan. Hello, Susan.
Good morning. Thanks very much, Adam. I'm Susan Grant-Muller. I'm Professor of Technologies and Informatics at the Institute for Transport Studies, the University of Leeds. That my research often involves a lot of pervasive technologies that are picking up very rich signal data. And so laser has provided a really great environment that's allowed us to explore that data securely and ethically in a way that we would have found very challenging otherwise. I'll talk about just two use cases, although I have had a number of projects that have used laser and are currently using laser as well. So the two use cases are shown here. The first one, we're working with some location data, fine-grained location data, which is around understanding some of the travel patterns and habits and needs of older people. So we're working with a transport supplier in West Midlands. We're using data that is sensor data that is collected through a software app, which has been downloaded by people who are older people, who are basically their details are stored within the databases that the transport supplier has, and they've given permission for us to contact them. So this is all done very much transparently and above board, but we've contacted them, asked them to participate in the research, to download a software app, and the app is tracking them in terms of their travel behaviours. So they hold this on their own phone, and it creates the kinds of data that we see on the top left-hand side of the screen there. And so it's fine-grained location data, which is sensitive for a number of reasons. It shows exactly where people are at particular times of day. It shows their regular routine in terms of their travel patterns. I think obviously with any member of public, this is it doesn't take much imagination to see how this could be sensitive data. In particular, with some older participants, it's even more sensitive. And as well as downloading the app, we've asked people to fill in a questionnaire which tells us something about their demographic characteristics, so their age, their gender, their income class, and other characteristics, which added together with the fine-grained location data is clearly a very sensitive set of data that we're handling there. However, being able to understand what the travel needs of some older people or other kinds of people who have particular vulnerable characteristics is really important for us to be able to create equitable societies to meet the needs of people, not just now, but in terms of the future design of transport services. So this is why it's very important that we're able to do this kind of analysis, but for obvious reasons, to be able to do it in a very safe and trusted environment. I've showed you some of the insights that we can generate on the right-hand image there, which relate to the travel patterns for people under the age of 55, and over the age of 55. We don't have much time, but we can see from this that those under the age of 55, probably by virtue of still being in regular employment, have travel patterns focused around the start of the day, the end of the day, but over the weekend, which is this period here, it's more dispersed around the whole of the day. When we look at people over the age of 55, we see that the pattern is actually possibly starting a little bit later in the day, but more spread out throughout the duration of the day. And we can drill down even more into this to understand where maybe female older people or male older people are most creating demand on the transport system, whereabouts they're travelling to, etc. So you can see how this could be really useful. And we want to take this into the design of future transport, such as shared autonomous vehicles as well. That's the first use case. The second one we can see here focuses on a new wearable that we've designed in a different project. This is able to pick up the kind of location patterns that we see here, but also picks up proximity. By proximity, we mean the closeness of individuals to other devices, which are generally carried by other members of the public, but could also be pervasive in the infrastructure and the environment. This has become a really important piece of work for us recently with issues around communicable disease, for example, on the transport system. So again, we're working with a national transport provider on this particular project. And the goal here is to understand how members of the public may be at risk from different kinds of communicable disease. So we can think of COVID-19, but there are many others, seasonal flu being one of them, and with many other instances where particular people are at risk. So the illustration we've got here shows a journey that people were taking starting from Leeds all the way up to Edinburgh, calling at different places. The train was calling at different places, I should say, along the way. And we can see we've picked up the volume of proximity instances as that journey has taken place. And for the individual who was travelling and wearing the device, we can see the extent to which they were exposed to close proximity to other people and potentially some health burdens as a result. So all of this can be used to design future short-term strategies for the transport sector, but also to inform people about their own personal strategies around transport and to help to design in terms of adaptations to reduce risk. The data is stored and securely accessed by our team of trained researchers in LIDA. The projects are separated into different VRE, trusted research environments. So people working on one team are not able to access data that people in the other part, in the other team are able to access. And as you can see, we can create the kinds of anonymized aggregate outputs that aren't betraying anything at all about the individuals, but can be used for policy insights. So thank you, LIDA team, and I'll hand over to the next use case.
Hi everyone, my name is Vicki Jenneson and I'm a research fellow in nutrition and lifestyle analytics at the University of Leeds, and I'm happy to share with you some of the ways in which LIDA has been really helpful for the work that we've been doing with supermarket retailers and our projects around exploring how transaction records can tell us about population diets and also uncover ways in which retailers can help to shift diets towards being healthier and more sustainable for the planet. So I suppose we've gone on a bit of a journey with our retail collaborators, and LIDA has been really important for being able to establish the trust that's allowed those partnerships to grow over time. So we work predominantly with basket level transaction records. So while these aren't sensitive data in the kind of traditional individual sense, they are commercially sensitive data sets, and LIDA, having that platform, respects the commercial sensitivity of these data sets, which then instills trust in our data partners. So that's enabled us to kind of grow from more smaller scale exploratory projects into much bigger projects where we're collaborating with more retailers. So just a quick example of something that we did in the laser platform was a data study group that we did with the Alan Turing Institute, and this was a quick kind of 2-week hackathon where people could explore real world data and kind of apply interesting data science methods to see what findings they could come up with. And we actually worked with early career researchers from right across the world. Everybody had completed secure researcher training, so we knew that they knew what to do in laser and would be safe handling that data, and were given university logins in order to access laser. But because laser's built in the Windows sort of infrastructure, it's really easy for people to go in there and just make a start with actually with learning and applying data science skills. So it's a really great learning tool. And it, also working with the DAT team, they were able to scale up as many virtual machines as we needed for that 2-week period. And then once that project was over, they could scale it right back down to just the one virtual machine that allowed us to keep storing the data, but we didn't need the usage ticking over time. So that's just a demonstration of the flexibility. But I think because, like I said, the commercial sensitivity of this data and the laser platform being so secure, over time, it's actually the retail sector have begun to talk, and we've become a trusted partner really among the retail sector, and are known for doing good and safe research with their data. So we are actually working with a number of partners now on the project with the Institute of Grocery Distribution, and we've published work that we've done with 4 different retailers to date. So that's great that we've kind of reached that status, and that's moving us through to a new project which is about to kick off next month. It's almost next month. So we'll be working for the first time actually with multiple retailers all on one single project, and in the way that Adam described, the laser platform allows you to keep each data set completely separate from one another. It gives trust with the retailers that no data can accidentally leak from one environment to another. It's all very safe and secure, so that allows us to comply with competition law and that type of thing. So it's just those really practical things that have helped to embed the trust with the retail sector and allow us to grow some really interesting projects that can develop insights not only for the retailers but also for policymakers as well. Thank you. I'll hand over to the next researcher.
Thank you, Vicki. And sorry, I realised I was on mute. Thank you, Susan, as well. Marlous, over to you.
Thanks. Can you pop my slide on? Great. So I'm Dr. Marlous Hall. I'm an Associate Professor of Epidemiology at the University of Leeds, and my work in laser today is focused on looking at a huge NHS, now England, data set of 145 million hospitalisation episodes for 34 million individuals across the whole of England over 10 years. So this is quite a beast, and the project actually started before laser existed, and it was a slog to get anything done with this amount of data, because the only sort of secure data storage that we had prior to this was seed, which was fine. It was very secure, etc., but it didn't have the kind of scalability and computational resource, and we had to invest in sort of specific hardware to do the project. But then when laser came along, things are much improved beyond that, because we can kind of scale up the Azure virtual research environment to the kind of level that we need to actually do this analysis. So actually that's been instrumental in being able to do this work. I just wanted to pick up on a couple of things that are really good about laser for me. So I was a little bit nervous about using it initially, thinking it was going to be a pain in terms of bespoke statistical packages, constantly having to ask for people to update things. In particular, if you work with R, you'll know that you need to update packages all the time. But the setup is really great. So despite not having internet access, the team have really worked hard to create this artifactory sort of space, which is like an airlock space out that you can access as a user directly from within LIDA. So without having to access the internet, you can actually update and upload your own packages from the CRAN as if you're just working on a normal computer. So that's really fantastic. The scalability is great. The flexibility of bringing in your own program licenses where needed. So there are some University of Leeds software packages available to kind of install and download easily. But for example, I often use Stata, but not the basic Stata version. I use a Stata MP64, which has got a specific license. So I was able to kind of add that license into the environment as well, which is fantastic. There's lots of team members with in the DAT team that have got experience in a range of different things. So there's a lot of support, not just with kind of moving data in and out of the environment, but also in terms of making sure your packages are working if things aren't quite right. That you know, there's varied expertise across the team, which is really great as well. And then again, that was something that was not available when I was just using the seed storage system. So it's a whole package and it's very easy to use. And Adam, could you just move to the next slide? So I don't want to take up too much time because I want to leave some time for questions, but just thought I'd put some quotes from my team as well who use LIDA in terms of what they've said about what they like about it. So Chris Hayward said it's really accelerated his research. It's very responsive and reliable, as in it doesn't crash very often. You know, you open it up, it just works as you expect it to do. It does sometimes crash because we're doing such crazy huge analysis, but on the whole, that's more a fault at our side than anything to do with laser. Johnny Batty, a PhD candidate and cardiology registrar, likes the fact that it's obviously very secure and it's very controlled in terms of accessing sensitive NHS digital data, but also that you can kind of leave things running and you can continue to develop code maybe on your own local machine without kind of clogging up all the RAM. So the RAM's kind of off there in the virtual cloud, and you can carry on working on your own computer while stuff's running. And also Charlotte Sturley, a postdoc in my team, just highlights how easy it is to access. You really don't need any specific training to use laser apart from kind of awareness of the security standards. You can just click on it once you're logged in. It just works like any other sort of desktop or machine. You can access it from home, which is obviously really helpful as well for flexible working. And I'll leave it there, I think.
Brilliant. Thank you, Marlous. So that brings us to the end of the presentation. Thank you all for listening. Thank you to those who spoke. Does anybody have any questions at all? Maybe you have some data that might benefit from collaboration with University of Leeds, or maybe you have some research that you need a secure environment for. Any questions at all?
Hi, it's Jeremy Warhurst here. Just a quick question. I've worked with data lakes, and one of the challenges that we had was with strategic versus tactical data. So we've heard a lot today about the strategic data that we're going to be using long term, and clearly that's got all the right sort of controls around it, which is great. Very often to do data analysis, there's a need for reference data, lookup data, lightweight, not particularly any kind of risk tactical data that may need updating regularly. I take it that there's a way to upload and update that without going through a sort of a full review because the source itself is deemed to be acceptable.
Yeah, so that those kinds of reference data sets are handled when they go through the same process as any data that's imported or into the laser. But that process is quickened by the fact that you know, we know the source, we know the content. It's reference data. It's not research data. So it is a lot more. Think of the words. It's a quick. It gets through that process quicker just by virtue of being reference data. Yeah. But we still do need to be, running checks against sharing agreements and whatnot, to ensure that reference data doesn't increase the risk. You can kind of, you've got to be conscious of kind of mosaic data linkages and all that stuff. So that's still considered. So there is still that process that it has to go through. But it is quickened by virtue of it being reference data.
Appreciate it. Thank you very much.
Thanks, Jeremy. I see we've got a hand in the air. Eric, do you have a question?
Hello, thanks for the presentation, Adam. Hi. Yeah, my query was, I just wondered whether or not you're familiar with Cyber Essentials accredited, because I know and you'll probably be aware that the university doesn't have an organisational accreditation for Cyber Essentials. There are lots of tender opportunities, for example, that we're excluded from by virtue of not having that accreditation. It appears that the ISO standard that LASER complies with may be a substitute for that. I just wondered whether or not you can comment on that, and whether or not running research projects in LASER would be a way of achieving that without having to be accredited to Cyber Essentials until the university actually does or doesn't get around to doing that.
Yeah, so I can speak to that briefly. I'd rather defer to our information governance manager, but she's not here at the moment, I'm afraid. She's not on the call, so I'll do what I can. Cyber Essentials, we have looked into that. We've looked into getting accredited with Cyber Essentials. There are a small number of requirements for Cyber Essentials that we currently would struggle to meet. I'm trying to think of one off the top of my head. I think there's a requirement for access to be only through managed devices. University of Leeds managed devices, encrypted devices, which, as LASER currently stands, it may be possible, but I'm not sure if that's the direction we want to move in, because it limits that collaboration with external partners more than we wish. In terms of whether ISO 27001 is a replacement for Cyber Essentials, I don't think it is. I think it's an alternative. I don't think it. I think that, but they are different standards, right? So, but it is an alternative, and it is a highly secure alternative that you could argue if somebody's if somebody was insisting on Cyber Essentials, I'd be happy to have a conversation as to what elements of ISO 27001 aren't met.
Great. Maybe I could send you an offline. I could send you an email, and we could perhaps have a quick chat. That'd be great.
Yes, I'll be happy to have that chat. Yeah.
Thanks very much.
Eric.
And thanks for the presentation overall, everyone.
Thank you. Kylie, put your hand up.
Hi, this is on behalf of the data scientist out here. I'm just curious to know if I would like to expand my domain knowledge. You were talking about the data pipelines that you would be creating for the projects that we uphold. Can we also be a part of the creation of the data pipelines if we are interested?
Okay, yeah, if I've understood the question correctly, yes, absolutely. I mean, those data pipelines are collaborative in nature. The creation of them is somewhat iterative. We've got to walk that line between security and utility, and a lot of that comes down to negotiation with data partners, designing the data product, doing what de-risking we can do at source, creating that pipeline into and out of LASER. We have several projects that kind of have bespoke data flows, that break away from the norm that's used for the majority of use cases, and those were designed not just by the DAT at all. No, it was very much in collaboration with the researchers, the people using the data. Yeah, absolutely. So your input would be welcome, 100%. Yeah.
Thank you so much.
Okay, nearly out of time. Do we have any more questions? I think we might have time for one or two more. If not, we'll end it there. Thank you, everybody. Thank you very much.
Thanks, Adam.
Thanks, Adam.
Have a good day, everyone.